Here the information given to us is sin A is 3 by 5 and angle A is greater than 0 but less than pi by 2. That means angle A is in the first quadrant. Now cos B is minus 12 by 13 and angle B is greater than pi, which is 180 degrees, but less than 3 pi by 2. That means angle B is in the third quadrant. Now we have to find sin A minus B, cos A plus B, tan A minus B and tan A plus B. So before we do that, let's find out the unknowns, which are cos A and sin B. Let's do that. Now cos B is equal to minus 12 by 13. So sin B would be equal to, so this time we have to keep in mind that B is in the third quadrant. So we need the negative square root of 1 minus cos square B, which is 12 by 13, minus 12 by 13 the whole square. So sin B would be equal to minus square root of 25 by 169, which is sin B equal to minus 5 by 13. Now the other information given to us is sin A is equal to 3 by 5. So if sin A is equal to 3 by 5 and A is in the first quadrant, we need cos A is equal to the positive square root of 1 minus sin square A. So this would be positive square root of 1 minus 3 by 5 the whole square. So this would be plus 9, this would be plus 4 by 5. That is the value of cos A. Now we have all the 4 values required to solve the question. But if you notice here, we need tan A and tan of A minus B and tan of A plus B as well. So for that sake, let's solve that too, which is tan A is equal to sin A by cos A. So sin A is 3 by 5, cos A is 4 by 5, so we would get 3 by 4. Similarly, tan B is equal to sin B by cos B. So sin B is minus 5 by 13 and cos B is minus 12 by 13. Minus 12 by 13. So we would get 5 by 12. See how accurate this is. B is in the third quadrant. So tan is positive in the third quadrant, correct? So in third quadrant, tan is positive. So we got a positive value here. So now we have all the trigonometric functions we need. Let's start applying the formula. So the first question is sine of A minus B. We are going to scroll up and down. Sorry about that. But I'll try to be as slow as possible so that you can see properly. So sine of A minus B is sin A cos B minus cos A sin B. Now what is sin A? 3 by 5. Cos B is minus 12 by 13 minus cos A is 4 by 5 and sin B is minus 5 by 13. Correct? So if we solve this, we would get, so the denominator is common, so that would be 65 and this would be minus 36 plus 20, so this would be minus 16. So the value of sine of A minus B is minus 16 by 65. Next thing we have to calculate here is cos of A plus B, which is CosA.CosB minus SinA.SinB. Let's apply the values. 4 by 5 multiplied by minus 12 by 13 minus 3 by 5 multiplied by minus 5 by 13. So the denominator would be 65. The numerator would be minus 48 plus 15. We would get minus 33. So cos of A plus B is minus 33 by 65. Now the next one is tan of A minus B, which is tan A minus tan B divided by 1 minus tan A tan B. We just found out the values here. Tan A is 3 by 4 and tan B is 5 by 12. Let's apply that. 3 by 4 minus 5 by 12 divided by 1, oh this is plus, 1 plus 3 by 4 times 5 by 12. So this would be 16 by 63. Now let's go to the next one. Tan of A plus B, which is tan A plus tan B divided by 1 minus tan A tan B. So we would get 3 by 4 plus 5 by 12 divided by 1 minus 3 by 4 plus 5 by 12. So we would get, let's find out the common denominator. So this would be, the denominator is 48 minus 15, correct? And the numerator would be, this is 4 times 12. And in the numerator we would have 36 plus 20 divided by 4 times 12. We can cancel this out. So we would get 56 divided by 33. So that is tan of A plus B. Thank you so much for watching. Please share this video with your friends and also subscribe to the channel. I'll see you in the next video.